Hey everybody, so we've been looking at solving some multi-step equations, and today we're going to keep building off of that, and we're going to look at some interesting cases that come out of solving some multi-step equations. So up here, I've got an example for you that we're going to go through together, and then we're going to look at a couple of those interesting cases. But before we go through this problem, let's make sure we know our steps. We have that step-by-step procedure. Make sure you have this procedure written down somewhere where you can access it, because you're going to want to use it for things like Delta Math or formatives or tests. You're going to want to have this step-by-step procedure written down somewhere where you can access it. So to recall, our first step is going to be T-chart. We're going to make our T-charts. That way it's organized and we have a step-by-step flow that we can write down. I'm going to draw a little squiggle here so we don't get confused between the problem and then the procedure. Step number 2, if you remember, is to simplify the expressions on both sides. So we're going to simplify those different expressions on both sides using combining like terms and the distributive property. Once we have it fully simplified on both sides, step number 3 is going to be to get x's, or I should say get the variable on one side. So a lot of times you're going to get problems where they have x's on both sides, or whatever the variable you're solving for on both sides, and you got to rearrange it so that they're all on one side. Because once they're all on one side, step number 4 is really easy. It's just going to be to solve the two-step equation. And we've practiced solving two-step equations. And so once you get it to step number 4, it's just going to be the same thing over and over. Get rid of the addition or subtraction, and then get rid of the coefficient. So we're going to go through our process here and use it to help us solve this problem. Step number 1 is to make our T-chart. I'm going to draw my T-chart in there. Then I'm going to simplify the expressions on both sides. So on the left side, I've got 3x, positive 4, negative 7. So I'm looking, okay, can I combine any of these like terms? Well, I can combine plus 4 and negative 7. 4 minus 7, that's going to give me negative 3. So I'm left with 3x minus 3 on the left side, and that's fully simplified. That's all I can do with that left side. On the right side, you might be thinking, oh, we've got 2 outside the parentheses. Let's jump right into the distributive property, and you can do that, and that's fine. But think about order of operations. I want to see if I can simplify inside the parentheses first. And since x and 2x are like terms, I can simplify that to be just 2 times. Once I have it to one single term, I can drop the parentheses. 3x minus 1. Now it's a little bit easier to work with because all I have to do is multiply these together. So the left side stays the same. 3x minus 3 equals 2 times 3x is 6x minus 1. So now I've got it to where it's fully simplified on both sides. Now I get to move on to step number 3. And step number 3 is to get the variable on one side. And remember from the last video, my hint was to move the least number of x's that you have to. So I've got 3x and 6x, so I'm going to choose to move this 3x. And how do I get rid of the 3x on this side if it's added to this negative 3? Well, I have to subtract it. When you're getting rid of the whole term, you have to get rid of it by addition and subtraction. When you're getting rid of just the coefficient in front of the x, then you get rid of it through division. So I'm going to subtract 3x here. So whatever I do on the left, I have to do on the right. These are going to cancel out and leave me with negative 3 equals 6x minus 3x is 3x minus 1. Then from there, I'm on step number 4, which is solve the two-step equation. First part to that is to get rid of the addition or subtraction. So I'm going to get rid of the subtraction by adding 1. -3 plus 1 is -2 equals 3x. And my last step is to divide by 3 to get rid of the coefficient. So x is equal to -2 over 3, -2/3. Okay, so now we're going to use that process and look at some interesting cases that might come up when we are going through and solving them. So if we get a problem like this, we're going to go through our step-by-step procedure. Step by step, we're going to go 1 is t-chart. Step number 2 is just simplify on both sides. Well, I'm simplified on both sides already, so I can go to the next step. The next step would be to get our x's on the same side. We already did that. All the x's are on the left. So now it's just solving it like a two-step equation. To get rid of that plus 1, I'm going to subtract 1. So I'm left with 3x equals 9. Then all I have to do is divide by 3, and x equals 3. So in this case, 3 is my one solution, because remember, the whole point to solving an equation is to determine what can I substitute in to make a true statement, because we're starting out with a statement, 3x plus 1 equals 10. When you multiply 3 times a number and then add 1, you get 10. What makes that statement true? 3. When you multiply 3 by 3 and then add 1, you get 10. So 3 is our one solution. We only have one solution to this problem because there's only one number that makes this sentence true. But then when we look at this one down here, we're going to do the same process, going through the same procedure, but something weird is going to happen. So in this one, start out by t-chart. Both sides are already simplified, so then I'm going to get my variables on the same side. And one thing that you should notice right off the bat is I've got the same number of x's on both sides. So if I choose to move the left to the right, I'm going to subtract 2x. But when I do that, it cancels out on this side. That was the whole point of subtracting it from this side. So you're left with -4. But then on the right side, 2x minus 2x, that also cancels out. So then on the right side, I'm also left with -4. So what's going to happen is sometimes the variables are going to cancel out on both sides and you're left with just numbers. Then you have to decide yourself, is that a true statement? Is -4 equal to -4? In this case, yes. If it's a true statement, so this is a true statement, which means that it's going to be infinitely many solutions. Infinitely many solutions. And you're going to be able to abbreviate it to just IMS. And the reason why we say it's infinitely many solutions is because if we look back at that original problem, if I erase what I've got going on here, I'm going to rewrite it so that way you can see it. 2x minus 4 equals -4 plus 2x. Whatever number that I put in for x, I'm going to have to do the same thing on both sides. So whatever number I put in for x, you're going to get a true statement. If I plug in 1 for x, I would have 2 times 1 minus 4 equals -4 plus 2 times 1. That's the same thing on both sides. If I plug in 2, 2 times 2 minus 4 equals -4 plus 2 times 2. Again, same thing on both sides. So whatever I plug in, it's going to make this statement true. So there are infinitely many solutions to this problem. So this first problem, there's only one solution. There's only one thing that you could substitute in for x to make that statement true. In this one here, There are infinite number of possibilities that you could plug in for x. Plug any number in. Because you have to do the same thing on both sides, it's going to come out to be the same exact statement. It's going to be a true statement no matter what. All right, so we've got one solution, infinitely many solutions, and then this one here is going to be a little bit different. So I'm going to erase this here, and I'm actually going to write it on this side, so that way I have a little bit more room. So I've got negative 3 times x plus 4 equals 8 minus 3x. So I'm going to go through my steps, use my t-chart. Then I'm going to use the distributive property to multiply that negative 3 in. And remember, you can use the rectangles if you want to. So I'll do that in blue down here. Negative 3x and 4 gives me negative 3x and negative 12. So then I'm left with negative 3x minus 12 equals 8 minus 3x. So already you should be noticing something. I've got a negative 3x here and a negative 3x here. So it's already looking similar to this problem because we had the same number of x's on both sides. But what's the difference about this one? The difference in this one is that this number and this number are not the same. Whereas in this one here, we had a negative 4 and a negative 4, and that led to us having infinitely many solutions. However, when we go through and solve this one, if I get rid of this negative 3x by adding 3x, then I'm left with negative 12 on this side. These x's also cancel out, so I'm left with 8. Now, in the last one, we had a true statement once the variables cancel out. But is this a true statement? Is negative 12 equal to positive 8? That is false. And because that is false, that means that there is no solution. There's nothing that you could plug in for x to make that statement true. So if I go through and erase this part here and rewrite what I have, so once I simplified it, I had negative 3x minus 12 equals 8 minus 3x. No matter what number I plug in, I'm not going to get the same thing. Because if I do negative 3 times 1 minus 12 and 8 minus 3 times 1, those aren't going to get the same things. Because what you're saying is negative 3 minus 12 is equal to negative 3 plus 8. That's not the same. If I plugged in 2, negative 3 times 2 minus 12 equals 8 minus 3 times 2. There's nothing that you could plug in to get the same thing. So that in this case, there is no solution. So we've got 3 different cases when we're solving equations like these. You're either going to get one solution where it comes out to be x equals a number. That number is your one solution to that statement. Or you're going to get it to be where the variables cancel out and you get a true statement, in which case that's infinitely many solutions. Or you're going to get a false statement, which means that there are no solutions. Let's look at a couple more examples to make sure this is clear. Okay, so this problem says to determine the number of solutions to the equation here. So in this one, when you're determining the number of solutions, you have 3 options. So you can kind of think about it like it's a multiple choice questions. You have A, 1 solution, B, infinitely many solutions, or C, no solutions. So right away when it says determine the number of solutions, it's like a multiple choice questions because you only have 3 options. It's either 1, none, or all of them. So let's go through and solve it and see if you can make that jump. Go through t-chart, simplify the expression on both sides. Over here, I've got negative 4 times x minus 5. So I've got negative 4x and positive 20, because negative 4 times negative 5 is positive 20. Negative 4x plus 20 equals, simplify on the right side by combining like terms. I've got negative 7x, negative 5, positive 3x. So the only like terms are on the outside here. Negative 7x plus 3x is going to give me negative 4x minus 5. All right, right when you're at this step, before you get your x's on the same side, you should check to see. If you have the same number of x's on both sides, that automatically means we can rule out that it's going to be one solution. So if there's the same number of x's on both sides, it has to be either infinitely many or no solutions. And then you can determine whether it's infinitely many or no solutions by looking at the other number. Since it's different, we know that when we add 4x to both sides in our attempt to get the x's on the same side, the x's are going to cancel out, and you're left with 20 equals negative 5. That is a false statement. That is false. And because it's false, it's got to be no solutions. So it's got to be no solutions. And what you can do is you can always go back and check. Plug in any number that you want for x. Maybe you want to put in 52. Plug in 52 for x. If it's different on either side, it's going to be no solution, because the only other option is infinitely many. That would mean that whatever number you plugged in, it would work. So once the variables cancel out, if it's false, it's no solution. If this were a true statement, it would be infinitely many solutions. And if the variables never cancel out, you'd only have one solution. So we're going to keep practicing with this. This is just going to take a little bit of practice to kind of see the patterns that form and kind of recognize what's going on within the problem. All right, so we're going to practice a little bit more with this. Otherwise, I will see you guys in class. Have a great day.